Welcome to DAT22103 Cloud Computing. This is Chapter 1, Introduction to Cloud Computing. In this chapter, we will understand the environment of cloud computing, its principles, how it is organized, and why it is important. The purpose of this chapter is to introduce the basic ideas of cloud computing. You will learn what it is, how it works at a high level, how it is organized, and why it is important. Chapter 1 is divided into 4 main sections: the introduction to the cloud computing environment, principles of cloud computing, organization in a cloud computing environment, and the importance and constraints of the cloud environment. We begin with Section 1.1, Introduction to the Cloud Computing Environment. Cloud computing is defined as the use of computing resources over the Internet, including servers, storage, databases, and software. Unlike traditional methods, it involves accessing shared, on-demand resources managed by a provider. This slide shows the high-level view of a cloud computing environment. There are 3 main parts. First, cloud service providers. These are companies that own large data centers with physical servers and storage. For example, AWS or Microsoft Azure may host their servers in regional data centers. Second, internet connectivity. The internet connects users to cloud services. Without internet access, users cannot reach cloud systems. Third, shared resources. These include virtual servers, storage, and applications that many users can use at the same time. For example, when UTHM students access an online learning system like Author or SMAP, they connect through the internet to servers owned by a cloud provider. They do not see the physical hardware. This is called abstraction. Users only interact with the service, not the machines behind it. Cloud services are grouped into 3 models: infrastructure as a service, or IaaS, platform as a service, or PaaS, and software as a service, or SaaS. These models define the levels of user control versus provider management. Now we look at cloud deployment models. Deployment models define where cloud resources are hosted and how they are shared. In simple terms, they determine who owns the infrastructure, who can access it, and how much control an organization has. First, public cloud. In a public cloud, resources are owned by a cloud provider and shared by many organizations over the internet. Examples of providers include AWS, Microsoft Azure, and Google Cloud. In Malaysia, a small online business selling products on Shopee might use a public cloud to host its website. The company does not own the servers. They simply rent resources from the provider. This model is cost-effective and easy to start, but resources are shared. Second, private cloud. A private cloud is used exclusively by one organization. The infrastructure may be located on-site or hosted by a third party, but it is dedicated. For example, a Malaysian bank such as Maybank may use a private cloud for sensitive financial systems. Because banking data is highly confidential, the organization requires maximum control and security. This model offers higher control, but usually at higher cost. Third, hybrid cloud. Hybrid cloud combines public and private clouds. Organizations can move data and applications between them. For example, a government agency in Malaysia might keep citizen data in a private cloud for security, but use a public cloud to host a public information portal. This allows flexibility while maintaining protection for sensitive data. Finally, multi-cloud. Multi-cloud means using services from more than one cloud provider. For example, a Malaysian university might use Google Cloud for email services, Microsoft Azure for learning management systems, and AWS for research computing. This avoids dependence on one provider and allows optimization of cost and features. Overall, deployment models represent a spectrum of control, cost, and responsibility. Choosing the right model depends on the organization's needs, budget, and security requirements. Next, we move to Section 1.2, focusing on the principles of cloud computing. Cloud computing is guided by 5 core NIST principles: on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. The first principle is on-demand self-service. Users can create and utilize resources instantly without human interaction, typically through a web interface or API, saving significant time compared to traditional provisioning. The second principle is broad network access. Cloud services are available anytime and anywhere over standard networks like the internet, supporting various devices for 24 hours a day, 7 days a week, 365 days availability. The third principle is resource pooling, or multi-tenancy. Cloud providers pool resources to serve multiple users. This allows for efficient utilization while maintaining logical isolation and secure separation of data for each tenant. The fourth principle is rapid elasticity. Resources can be increased or reduced quickly based on demand. This auto-scaling capability provides the consumer with the perception of unlimited capacity and ensures cost efficiency. The fifth principle is measured service. This means the cloud system automatically records how much you use. You are charged based on your actual usage, not a fixed amount. For example, the slide shows a traditional cost of $5,000. With Cloud Pay as you use, the cost is only $1,200 for a lighter workload. The usage is also clearly measured: 40% computing, 35% storage, and 25% network. So you can see exactly where your money goes. It works like an electricity bill. The more you use, the more you pay. If you use less, you pay less. We now move to Section 1.3, Organization in a Cloud Computing Environment. Effective organization in the cloud is crucial for managing resources, controlling access, tracking costs, and reducing mistakes. Cloud resources are structured in a hierarchy from the organization node down to projects or folders, and individual resources. Cloud resources are separated into accounts or projects to organize resources and environments. Commonly, these are development, testing, and production environments to ensure stability and quality. Identity and Access Management, or IAM, is the system used to control access. IAM determines who is accessing the system and what actions they are authorized to perform. Now we look at high-level networking in cloud computing. Cloud resources operate inside virtual networks. A virtual network is like a private digital space where your servers and databases communicate securely. Inside this network, services talk to each other. For example, an app server connects to a database. This is called internal communication. It is fast and protected from public access. External access is different. This allows users to connect to the system through the internet, usually through controlled gateways. For example, imagine UTHM online portal. Students access the portal from their laptops or phones. That is external access. Inside the cloud, the web server communicates with the database securely within the virtual network. So even though everything is online, networking still controls who can access what and how services communicate safely. Tagging and ownership involves labeling cloud resources with metadata tags. This helps organizations track who owns a resource, what project it belongs to, and which environment it is used for. Finally, we cover Section 1.4, Importance and Constraints of the Cloud Computing Environment. Cloud computing is important because it enables organizations to start systems quickly, adjust resource usage easily, and avoid large upfront hardware purchases, supporting flexibility and faster deployment. However, cloud computing has constraints. These include increased cost if resources are unmanaged, dependence on internet connectivity, and a learning curve for new tools and concepts. Now let us look at cloud computing from a balanced perspective. Cloud computing is powerful, but it is not automatic and not risk-free. We must understand both the benefits and the constraints before making decisions. First, the benefits. Cloud provides speed. For example, if a company wants to launch a new system, they can deploy servers within minutes, instead of waiting days or weeks for hardware setup. It also offers flexibility and scalability. If demand increases, resources can scale up. When demand decreases, they scale down. This is useful during events like online sales, where traffic suddenly increases. Another advantage is cost efficiency. Organizations do not need large upfront investment in hardware. They pay only for what they use. However, there are constraints. Cloud is not automatic. If systems are poorly designed, performance problems can still occur. It requires planning and risk management. For example, if unused virtual machines are left running, costs can increase quickly. There is also a learning curve. Teams must understand new tools, security controls, and cloud architecture. This is why we have what is called the success triangle. First, proper planning. Second, clear organization. Third, responsible usage. Without these three elements, cloud adoption may fail. So the key idea is simple. Cloud computing brings many advantages, but success depends on how well it is planned, organized, and managed. As future IT professionals, you must understand both the opportunities and the responsibilities that come with cloud technology. In summary, Chapter 1 introduced the foundational concepts of the cloud environment, its core principles, how it is organized, and its importance and limitations. This foundation is essential for later technical chapters. Please take a moment for a quick self-check. Consider defining cloud computing in your own words, naming 2 principles, explaining the importance of organization, and stating 1 benefit and 1 constraint. Thank you for watching this video. Cloud connects the world, so let us build it securely and wisely.